Hello everybody, and thanks for coming to my talk on Android high performance. I hope you enjoyed yesterday, the Trump party. And before I start, I have to say that when I was 18, I used to go partying and drink 27 beers and things were great. But now I drink 27 beers and my heart is hurting a lot. I think that has something to see with global warming or governments to do something about that. Yeah, as I said, I want to talk with you guys today about Android high performance and how to make an application, a great application great, and make it performant and make it run smoothly. This is my ego slide. I'm an IT consultant. An IT consultant is pretty much a programmer, but it sounds cooler, and actually people pay you when you say you're an IT consultant, because as a programmer it sounds a little bit like, yeah, script kidding. I'm part of the Google Developer Expert Crew, together with another bunch of GDs here in the hall. And this is my Twitter handle, so you can follow me there. I try to be active with the community. I will post later my slides, and you can ask me anything if you want. I'm originally from Spain, from the city of Madrid, but live in Munich, and I've been living there for the last 9 years now. So pretty much getting used to the cold weather. And yeah, how did everything started for me with Android high performance? Well, almost a year ago, I was contacted by Pack Publishing, and they asked me, well, would you like to write a book on Android high performance? And for me, it was like, well, why not? I think that's a strategy to follow in life. Always say yes, and then try to figure out how to do things. And for me, it was a process, an entire process of revelation, because I used to work, of course. I've been developing for Android since 2008. But I never really focused on making applications really performant, so it was also a process of learning. I had to focus, I had to actually write code, test it myself, decompiling, see exactly how much memory it was taking, etc. And I think I learned more of writing the book than I'm actually teaching to other people. And well, when we talk about, now there is a lot of trends about high performance, and you go to many conferences and people talk about performant applications and performant software, etc. Well, the definition of performance is how well a person, a machine, etc. does a piece of work or an activity. This is a Cambridge definition. But when we talk about software, what does it mean exactly high performance? Well, those are strategies that we use to create software that is efficient. And particularly when we are talking about mobile devices, this talks about energy and battery. We want our device to make a smart consumption of energy and battery, because in a mobile device, this is limited. It's not like a desktop computer where we can, it's connected all the time to an energy source, and we don't really have to care a lot about that. This is a big issue on mobile phones. It's also about programming patterns. When we are developing software, we want to make a smart usage of patterns. So we ensure that the software is going to be maintainable over time, and more people will be able to work in the future. We don't need to rewrite it every year because it got totally unreadable, etc. It's about designing nice layouts. We don't want to have a crazy hierarchy of views that need to be redrawn every time and that make the software slow. And we see that the precision when we are opening a screen is slow and buggy. It's about security. We want to make our software safe. If we are saving passwords, if we are dealing with user data, we need to make sure that this is going to be stored securely and no attacker, no hacker is able to access our software. It's about multi-threading. We have different strategies to make components talk with each other, and we need to know exactly which components should we use and which different multi-threading strategies should we apply. And of course, it's about debugging techniques. When we debug I was talking with one guy in a conference, and he was like, well, I don't really need to debug the software. Nice, he was a very nice programming. But in general, we will need to go into the debugging details. We will need to use the tools that Android is providing us and be able to access the memory and see exactly how things are going, etc. Well, why is this important? We need to keep the user engagement really high. That means the people that are using our software, we want them to return and we want them to use our services. It's about cost. When we are not developing efficient software, cost will skyrocket because we need more people to maintain the software is buggy, etc. And it's about the quality. We want our customers to provide, we want to provide them with a really nice user experience. We can face, actually, when you need to justify those things to managers, it's always good to talk about the financial aspects. Why it's important to develop efficient software? Just tell them, because if not, it's going to cost you money. Everybody understands when it's a money problem. And we can face actually different financial loss, different losses from monetary losses from not developing efficient software. We can have financial losses from lost business. If you remember the case of the infamous PlayStation network, they had some problems with data that was stolen, so people was not returning and buying their services. They had to pay customer reparations, right? Because if people steal your credit card, you need, and they actually use it, you need to repair actually your customers that lose money because of you. And of course, you have the financial loss of lost customers. No new customers are coming to you. You will eventually have to face legal consequences and pay for the lawsuits, etc. And you will have a lower brand equity for your organization. There are three important limits when we are presenting software, when the user is interacting with software. The first one is 0.1 seconds. This is the amount, the limit for the user to have the feeling that the software, the system, is reacting instantaneously. So meaning that in this case there is no special feedback to be provided for the user. The second limit is 1 second. This is the limit when the user, the flow of thought, starts getting interrupted. They will notice the delay, and in this case normally there is no special feedback that needs to be provided, but over this amount, and until we reach 10 seconds, is when the mental state of the user stops being focused on our application. They will go out and stop using it. This is actually a study that was done by Miller and Carr, and you can Google for that, and it's an entire paper that they published on user UX interaction and how to deal with software, and it's a really nice read. What this means in Android. INR. What is an INR? Somebody knows? I hope so. No hands? No? Yeah? Jorge? Application not responding. That's this typical dialogue that if you're developing for Android happens if you don't follow a good procedure to deal with to develop the software. This happens every time there is no response for an input event in 5 seconds. That means I click on the screen, 5 seconds, nothing happens. The operative system triggers this ANR dialog. Or if a broadcast receiver is still executing after 10 seconds. How do we want to avoid this? Well, if we are doing a background operation, we want to show feedback. There are different ways to do it in Android. We can use a progress bar. There is the progress bar or the one that is a circle. We should always use them or a similar indicator every time we're performing operations on the background. Also, there is some controversy regarding splash screens because it's not a pattern. Cyril Motier a few years ago wrote a really nice post about it. Avoid the splash screens, they are really bad. Well, I think they make sense sometimes, and also depends how you're doing the splash screen. There is this really nice example here of a splash screen, vaporware, and if you see it, it's really smooth. It makes sense. It keeps the user engaged, and it might be necessary at some times. You need to download some information from the backend, or you need to connect remotely and do whatever operation. So splash screens should be avoided, yes, but if you're going to implement it, there are beautiful ways to do it as well. And well, in general, if you are doing any calculation, you should use a worker thread. Don't keep the UI busy. We have a few tools that we can use to debug those things. One is the systray, the other one is the trace view. And if you've been developing for Android, you will know probably the DBMS, which stands for Dalvin Debug Monitor Server. And I hope everybody knows it, but just in case not, I can browse briefly in here. And so how it works, yeah. Yeah, so the Android device monitor, if you develop for Android, that should be one of your best friends. It's pretty much one of the tools we can use to develop our application. We can see here on the left side the devices that we're connected, that are actually connected to ADB. Those are the processes that are actually being debugged. And here on the right side, we have a few options to debug actually our software. We can see the threads that are active. Here we can see the status of the thread, the U-time, the S-time. Do you know, who knows what is the U-time here? Or what does U-time means? Somebody knows? Okay, so U-time is actually, it comes from the Linux word. You know, Android is based on Linux, and is a unity of time to see how long has been the thread running. DS is the accumulated one. We can see also the heap status if we enable it on the client. So if I click here and then cause a GC, we will be able to see how much, how is the memory status, how much objects I'm allocating. This is very interesting when you're having memory leaks, because you can see exactly, oh, I'm having whatever, this data type is being allocated very often, so I might have a problem in this thread or with this object. We have also the allocation thread tracker here, the network statistics. The network statistics are really nice because we can tag actually our sockets, and we can see exactly where the network connections are being started and which thread is the one that is using a lot of our connections, of our bandwidth. We have also the file explorer that we can use to access the files on our system. Emulator Control to handle a few more things, like simulate voice calls. We can change the data speed, simulate incoming calls or messages, change the location, etc. And yeah, of course, the system information that shows us the CPU load, memory usage, etc. Let me now come back to, if I can stop mirroring. I like to make demos and to show always software on the screen, but this is also very tricky because sometimes software stops working. There is this god of demos that is actually a pretty bad god. Yeah, that's what I showed you before. And well, I told you about the networking. When we are making our HTTP calls and our network requests, we can actually make use of a very nice feature, which is tagging our network calls. So if you came here, we see that we have two tags. One is for the total of the internet connections. The red one is for a particular process. In this case, there is no red one because the red one didn't start it. But on that way, we can see exactly from where our network connections are coming. Debugging layouts. When we are watching TV, we have this rate of 24 frames per second. That's the standard NTSC in America. 25 frames per second. That's the PAL standard that we are using here in Europe. And new camcoders on slow motion are up to 48 frames per second. So in the television and with this rate per second, blur can still occur. And when we go to applications, we are having a refresh rate of 60 frames per second. That's crazy, and it's much more than the television. It means that every 60 milliseconds, there is a data refresh. And there are a lot of things that can make this deadline not to be respected. For example, it can happen that the view hierarchy is being redrawn too many times, taking up too many CPU cycles, and if this is happening, the frame is dropped, and the UI is not refreshing, giving the user a perception of fluency. So, and this happens pretty often. So there are a few techniques that we can use to avoid this and to make our layouts more efficient. This is how typically a view hierarchy looks like. Can you guys see something here that can be improved or that can be optimized? Any ideas? Okay, if you go at the top, you will see all the Android view hierarchies are using a decor view. What is a decor view? It's a holder for our views. But what happens when we're developing any application, we already have our own view that is under this view holder and is occupying the entire screen. So the view holder, it's meaningless. It doesn't really have any purpose, and it needs to be drawn anytime, the consuming CPU. So an immediate optimization that we can do on our Android application is adding this to our style, setting the Windows background as null, because we are not going to very likely need this Windows background. We will have our own screen taking care of that. We can also reuse layouts. I think Jorge mentioned that in his talk yesterday. In Android, there are a few ways we can apply to reuse layouts. Let's gonna take a look on this layout. There is a linear layout with an image and a text view, pretty simple, that very likely we will need to be using in through different states of our application. So if we use this include, you can guys see the second XML tag. We will be able to include this layout through different, through all the different, or reuse it in different configurations. But there is still another problem. By doing this, we may introduce some redundancy because we are adding a new group as the root node of our reusable layout. So even better, we have this merge layout, or this merge tag. That means that the merge will take care of actually merging and reusing the layouts on an efficient way. More things we can do. ViewStop. Who knows the ViewStop? Can you raise your hand? Okay. So for those who don't, the ViewStop is pretty much a class that can be added as a node inside the layout hierarchy, specifying a layout reference. And it will be inflated on runtime every time we're calling inflate or set visibility. So pretty much by doing this. Using ViewStubs can also make our layouts more efficient. When it comes to debug, Android provides us with this hierarchy viewer. This is a tool where we can actually select our application and we will see the entire hierarchy view. This comes very handy, particularly because, okay, we define our layouts right, but we have then things such as a recycler view that gets instantiated and inflated on real time. And it's not easy to see if there is going to be any problem until the recycler view, for example, is actually instantiated, inflated, and we have all the components. So by using the hierarchy viewer, we can actually see which components are being drawn or not. Also, if we are rendering the GPU, we have a few developer options. We actually have a lot of developer options inside our Android operative system. This one I think is particularly very, very useful. And it will show the rendering times that our our GPU is using. So we can see, okay, there is like some problems when the thread is being prepared, when it's actually drawing, or when it's actually executing, etc. So we have a color code here. It would be good to check it. So the blue is actually the time spent drawing the interfaces. The purple is the time the GPU is preparing to draw them. The red is the time is being taken to process it, and the orange is actually the execution time, which is this thing here. Well, more things talking about efficient layout. Memory. Memory is the ability to remember information, experiences, and people. This is also a Cambridge definition. And there are a few misunderstandings and bad practices and good practices when we are developing Java software or Android software. Classical one are enumerations. Do you guys think enumerations are generally good or bad? What's your guess? Bad? How many people think they're bad? How many people think they're good? Okay. Well, enumerations might make sense, but the problem is that they are not very efficient when we are implementing them. This is how a typical enumeration looks like. We have a shape, and inside this shape we can have different types: the rectangle, triangle, a square, and a circle. Well, we could as well have a public class, right, where we are making our enumerations as static final variables. And the thing is, which one is better from a memory perspective, this one or this one? Well, the answer to this question is twofold. The best thing to do those things, I actually did it when I was writing this book, is creating several examples, compiling them, and then checking the dex size of the file that was being produced, and then seeing exactly how big was the memory usage and the heap memory, etc. In this case, our example enumeration is being converted into 4 objects allocation with a string for the name and an integer value as the ordinal, and an array in the grapper class. So instead, this class implementation will be lighter because it allocates just the 4 integers values with a considerable saving of memory. So this option is going to be better from a memory perspective. So we will call actually, if we have we need to call a function that is going to calculate the surface. If we are using the enumeration alternative, it will look like this. Whereas if we are using using a public class, it will look like this. But in Android, we have something that is really cool, and is the in-def annotation. Have you guys used it? How many people use the in-def annotation? Okay. And well, this is very useful because it simplifies a lot the transition from enumeration into integer values. Let's look at this example. We are still having our static final integers, rectangle, triangle, etc. And here we will define an interface called shape with the annotation in-def, passing its element as an argument to the annotation. So look how cool it looks here now. If we're going to have a function called setShape or getShape, we can use an annotation called shape that will actually represent it will actually represent the values we have written here. So it's if you need to work with enumerations, please check InDev, because this will be one of your best friends. So as a summary, if we are using enumerations, we are creating unnecessary allocations. So in general, it's a good practice to avoid them and use as much as possible static final integer values. Again, this is not something that will be an extremely big deal, but we want to develop efficient software from the beginning, because when we are developing small things, they are always going to work, but the process of software engineering is about handling increasing complexity. The hello world will always work, but we want many hello worlds that have interactions between them, etc. And it's a good practice always to do things right from the beginning. More thing, constants. Constants in the code should always be static and final to take advantage of the memory savings and to avoid initializations in a Java compiler. I think that's something that everybody does it, but it's as well good to remember it. Strings. This is how a string looks like. How many people think here that the strings are good? Yeah. Well, strings are good, right? It's this primitive we have to create string values and characters, but it has a few problems. So string objects are actually mutable. So every time we're instantiating a string with new, we are forcing the allocation of two different objects. So in this case, we are allocating the string example, that is an object itself, and we are allocating the new string as well. So there are better ways to do it. We could use a string buffer, yeah, exactly. So in this case, what we are actually, this string buffer and the string builder are actually more efficient than the classical string approach, because they work on character arrays. So for a better execution, this should be changed into something like this. We will have a string buffer, and then every time we need to add new content, we will use the append function. And another thing to keep in mind when we are using the string buffer is that they have an initial capacity of 16 characters. And every time we need to add new content, this will get double. So that means from 16 into 32 into 64, etc. Meaning that at some point, it could be that we are having a space in memory that is not being used, because let's say we need to allocate 55 characters, and we have initialized with 64. If we have some clue at the beginning on how big we look our string, we can always pass this size as an argument. Here we have passed 64, so we will control more efficiently the size of this string buffer. Memory leaks, our worst enemy when we are developing applications. This happens when a resource is still allocated, even if it's not many more being required. And if we develop for Android, there is this classical thing of activities that are being loaded, fragments that are being unloaded, etc. So it's very easy that this actually happens. This is the definition of Wikipedia. Can you guys see something wrong in this code? Anybody, any volunteer or everything? What's wrong? That's right. Well, we have a static view, right? And that means that this view will be recreated all the time. So anytime the activity disappears, we will likely have a problem here. Because look at the constructor of the view. The context need always to be sent, right? And even if the context is disappearing, the static view will still be there, etc. So when we are working with the static fields, we need to be very careful and see exactly when the value is going to be used and when not. Also, another problem are the non-static inner classes. This is a classical example that you see. Now I work as an IT consultant, so I have access to a lot of code from many companies, some very big companies in Germany, and I see this very often. That was maybe an approach that at some point was widely used in the Android world, and it's something terrible, because we have this Asynctask that might leak very easily. To solve many of these problems, we can actually use weak references. Jorge also mentioned that in his last talk. So a weak reference pretty much is, who doesn't know weak references here? Okay. So if you don't know them, you should actually read about them as soon as this talk finishes, because this is going to be something that will help you a lot to avoid all the memory leaks. So by using weak references, the classes are separated and the activity can be collected as soon as there is no more usage in this example. So here we see that The main activity is referred as a weak reference, so it can be collected at any time. Threading. Well, threading is a method of hair removal originating in Asia. That's the Wikipedia definition, but probably doesn't apply to us in this conference. Well, threading is as well the smallest sequence of program instructions that can be managed independently by a scheduler. That's the Wikipedia definition as well. Well, there are a lot of options of how can we use threading in Android. We have an Asynctask, we have loaders, we have threads. And at this point, the important thing is that we need to know the war we're fighting. We need to know the battle we're fighting. And by knowing all the solutions, then we can decide on, should I apply one or the other technique? Well, if when to use Asynctask, for example, that's pretty much the one of the most widest solutions used in Android. In general, if we do not need to communicate with the UI and we do not need to notify the user, we do not need an Asynctask. And if the you see also very often that many, when we are declaring the Asynctask, there are these parameters or these that we need to specify, and many people just specify them as void. If you specify them and void all the parameters, then you're only implementing the doing background method, and therefore you do not need an Asynctask either. If you end up anytime implementing an Asynctask with void parameters, then remove the Asynctask. You don't need it. The Asynctask loader. This is another component from the Android SDK. Well, it's typically can be used to fetch data, and it has the same features as Asynctask, so it will pretty much look like an Asynctask. But additionally, it has is independent from the activity lifecycle, and it provides some data caching. And it can actually be implemented like this as well, pretty easily. So that's as well a good alternative to the Asynctask. Well, the services in Android. We can define activities, we can define services. Services are per se not threads. They are executed in the UI thread by default. They should never be started for a long-running operation, and they have their own life cycle. So that means a service can start, can die, etc. Intent services, another component. They're a particular implementation of a service, and what they do is they execute sequential operations in the background. And the good thing with the intent services is that we don't need to handle the life cycle, so they get easy to implement. Networking. The process of communication between different terminal nodes to exchange data. That's my definition, because I couldn't find one in Wikipedia, but I'm sure there are a lot of definitions somewhere. Well, when we talk about networking, we can as well define a lot of strategies to apply to communicate with an external web service and be able to fetch data. One of them is the latency gouging. So that means when we are going to make a request, we might be under different conditions. We could be connected to a Wi-Fi network. We can be connected to the mobile network. The Wi-Fi will generally be faster than the mobile network. But even in the mobile network, we can have like different speeds. We can know if the speed is LTE or the speed is GPRS. So take a look on this code. If we organize something like this, we can decide, okay, now I'm connected to the Wi-Fi, so in this moment is when I will start downloading all those big images that are taking a lot of space. That's a really nice practice that you can start applying. If you need to download big things, let's say images, audio resources, etc., try to do it when you're on a Wi-Fi connection, on a Wi-Fi network. And we can do more things, apply more strategies. Batch connections. The principle here is to wait, collect our data, and then send it. That's something that is applied in most of the analytics SDK. If you check Google Analytics, they don't send all the data immediately. You can actually batch it, so when you have a big chunk, you will actually send it, sending these constantly opening connections and reopening them. Another strategy to consider, if the data doesn't need to be communicated immediately, group it, make small chunks or bigger chunks, and then send it. We can also prefetch data. So the process of prefetching the data is downloading as much as possible when the connection is idle, and so we can present it faster to the user. Let's say we are in a screen and we know if in the normal flow of the user will require him to download some information later, well, do it when the user is reading, because that will be done on the background. You can actually use this idle time to provide the user with a better experience. Or queuing connections. We can also, if we see at this very small class, what we do is we can start grouping the request when we need to send a bunch of time. This will reduce the amount of time that the radio is turned actually on. If the requests are not executed immediately, they will be batch for future batch connections. And as you see, this is a very easy solution to implement. We can cache the responses. Is our data going to change? Does it need to be updated constantly? If the answer is that, okay, the user will be able to live with this amount of information being cached, well, use it. Don't make the request all the time. This will save you also a lot of battery and a lot of internet consumption. Or LastModified will be another strategy for the networking aspect. You can see if the use these kind of headers to see when was the last time that the resource was modified, and in this case, you will get updated data or not. Another strategy I like a lot is the Exponential Backoff, which means sometimes the resource can be not available, there could be any problem. Well, in that case, you don't need to make the request constantly. If something is down, let's say a web server, it will likely be down in the or unavailable in the next periods of time. So by using an Exponential Backoff, you can make sure that the request is not going to be firing immediately. You will be waiting. You make the principle of the exponential backoff is that the time is growing exponentially, so you don't make the server exhausted and consume your own battery and your own energy by making the same request all the time. But try for some time, making the exponential time between requests longer until you give up. Well, and that's been everything. I actually like a lot to get feedback from people. It helps me a lot to prepare next talks and get to learn what people enjoy more or less. So if you leave me your feedback here, your honest and critical feedback, I will give you a copy of my book, 100 Questions and Answers to help you land your dream Android job. I actually started writing this book when I quit my job because I wasn't sure if I was able to find a new job. I used to write a lot of questions at my previous position to interview people, etc. And I think it's quite interesting if you are looking for an Android position. So thanks everybody for being here. If you have any questions or some aspect you would like to discuss. No questions? Well, thanks again for being here. It's been a pleasure, and if you want to discuss it later, just come here, write me on my Twitter, or grab me at any time during coffee. Thank you.